Okay, let's take a look at Tutorial 2, question 1e. Can you find the portfolio opportunity set and the efficiency set? So let's take a look at these problems. Okay, so the expected return on the portfolio, well, this depends on the weights. Depends on the weight in omega A and the weight in omega B. The expected returns for acids A and B are fixed. Let's just play around with this a little. Actually, the weight on the acid B is just 1 minus the weight on acid A. And we can simplify this. We collect together all those omega A's. We think of omega A as varying, and all these expected returns as constants. Okay, so the expected return on the portfolio, we can think about this as some function which depends only on omega A. So this is a function of omega A. Everything else are constants. So we could plot this simple 2D plot. We could say what happens as the weight for acid A varies, and what impact does that have on the expected return on the portfolio. Well, if we ignore shorting for a moment, we can see up by here. This is just a straight line, goes through this value when omega A is 1. We have this value, and so we have this straight line like so. And if we allow shorting, of course, this could continue this direction and this direction indefinitely. Okay, so we have a geographical representation of the expected return on the portfolio. Next, well, we could express the weight omega A in terms of all these expected returns. We write in of terms, should say 4 for omega A. This is going to help us find the opportunity set because the portfolio variance contains omega A, omega B. Okay, so some simple rearrangements. Omega A. Okay, so we need to take the portfolio expected return, just rearranging up here, subtract the expected return for the acid B, and divide out by that gradient term. Okay, and that gives the weight omega A. Similarly, we can do the same for omega B. Okay, this is just 1 minus omega A, so it's just a simple fraction. A little bit of rearrangement. Okay, a little bit of playing around with the fraction. Simple enough to see that we get this. Okay, so that is the returns on the portfolio. Actually, we want the portfolio opportunity set. So we want the expected return as a function of the variance. Okay, So the variance, let's do that next, is the standard formula, which we should know, and we can use the formula sheet just to confirm if there's any doubt. Okay, and we can drop the omega a's into this. So the first term, omega a squared, is this one. Then we have the variance for acid A. Okay, so then we have, let's drop in omega B here. This is squared times the variance of B. I've just noticed I've missed some factors off here. This should be omega A, omega B. Okay, that final term, 2 times the covariance. This is just some constant. We actually know what this is. Omega A, omega B. So omega A, omega B. Okay, and we need to multiply all of this out, and the only thing we're going to allow to vary is the expected return on the portfolio. Everything else is a constant. So we know the expected return on asset A, asset B. We know the variances of A and B. We know the covariance. We're just going to let the expected return on the portfolio vary and see how this impacts the variance on the portfolio. Okay, so there's a lot of multiplying out. I'm not going to go through all the multiplying. I'm just going to do it on a separate bit of paper and save time and space. So if you multiply all those out, you will get the portfolio standard deviation is the square root of the following. Okay, you should check this for yourself. Okay, it's the following quadratic, which is being square rooted. And there you go, we have the portfolio standard deviation as a function of the expected return on the portfolio. So we could put this into a nice sketch. How much room do I have? Yeah, that's fine. So when we calculate the opportunity set, we want to vary the risk on the x-axis, and we want to see the expected return on the portfolio as a function of this risk. Okay, I think I go back to the thicker color. Okay, we know from lectures, and we can see from this function, that the shape of the graph is a quadratic on the side, roughly like this. The last one didn't help. And some interesting features. This point here is the minimum variance portfolio, and we know from the previous examples the minimum variance on the minimum variance portfolio is 9.7098, and the expected return on this portfolio is 12.4262. That's just from the previous examples. Okay, so the different things we need. So one of them was the opportunity set. Let's go back up. So we got the portfolio opportunity set and the efficiency set. So the opportunity set is the whole thing, the orange, and the efficiency set is just this part of the graph here. Okay, so let's write them. The opportunity set, so this one is the whole thing. This is the orange. Well, we have all the points such that, well, we just have this, we have an explicit form of the graph, so such that this holds, this form holds. Okay, so that's the orange graph. And the efficiency set, which is in green. Similarly, we have all the points such that, well, we only want the green part, so we want the, how can we describe that? The expected return on the portfolio to be greater than or equal to 12.4262, and we want all the points to be on the graph. So there you go. These are all the steps for calculating the opportunity set and the efficiency set for some portfolio.